This is the next video in our series where we use Gemini, that's Google's AI, and we use a Google Colab notebook as our research environment. And we're going to look at summary statistics and data visualization of a categorical variable. Now, once again, there's a couple of categorical variables in our data set. Please watch the series from the beginning so you are up to speed. And I'm going to show you how to do that exploratory data analysis for this categorical variable, but you can play with the rest and practice a bit. So let's use Gemini, the AI, to do some data analysis. So we're back in our notebook. I'm just continuing with the code as before, so I don't have to re-import the CSV file. But do remember, if you do go away, if you do close this down, come back, you'll have to re-import this. You can watch the first video just to how to do that. I want to continue with this univariate exploratory data analysis. So I'm still at exploratory data analysis, univariate. I've done age. I want to do one of the other columns. Let's just go back and have a look at this data import section. Let's have a look at those. Let's do chest pain type. So we see chest pain type. It is the third column with index 2. It's got 918 non-null values, so there's no missing data there. And the object type, or the data type, is object. And that means it is just strings or characters in the rows of that column, which means it's going to be a categorical variable. So chest pain type, you see they've used this uppercase of each next word. Very important when you create your data files. If you're in charge of creating either the database or the spreadsheet file, do yourself that little favor. Don't put spaces in between. Do either the snake case, as we can see here in index number 9, st_slope, your st segment slope, and chest pain type, two different ways, snake case or just this called camel case, whereas specifically camel case will put that first letter as a lowercase and every subsequent one uppercase. This all uppercase, just different ways, different formats. But that's the one that I want to go for. So chest pain type. Let's go down. Remember, I'm still doing my univariate. That was 4 hashtags. I'm going to continue with the 4 hashtags. So let's do a nice little text cell there. 4 hashtags. I'm going to do chest pain type. Now, once again, if I used one of or more of these text cells just to have a data dictionary, you can do that. Or you can just say here, put a little text cell and just describe what this is going to do. So the first thing that we might want to do here is just to look at the unique values and count how many of these there are. In other words, how many categories are there? And I want the frequency or count of each of these. So I can put that in a text cell. So there we go. I've typed calculate the frequency and the relative frequency, that's the proportion of each category in the, and I'm using that LaTeX typesetting again. I'm just going to stick to that formatting. I showed you that formatting, and I want my document to look nice. I'm just going to repeat the same thing, just keep it consistent. And there we go. We can see the chest pain type is a true type font. It looks slightly different from the rest, stands out. I think it's quite nice and neat. So let's do that. I'm going to generate some code this time. So let's type. So there's my little message. Calculate the frequency of each unique value in the chest pain type column. I can be more elaborate. I don't want to see any print functions. I just want the shorthand, but we're just starting off. Let the AI do its job. I'm going to send this. And there you go. You can see it's done this elaborate thing again by creating a computer variable, and then it sends that to the print function. It's just too much work. So what I'm going to do here is just to accept that for now. I just don't want to execute that. And I'm going to manually make things easy. I'm going to take all of this away. You don't need to do this. It's perfectly well as it is there. It's going to execute nicely. I don't want that. That's just, just an extra bit of code that I really don't need. I'm going to delete that. And I'm going to delete this whole assignment, because the beauty of a Jupyter notebook is if you create something, it's going to print it to the screen. If you created something in a different IDE, maybe an older IDE like Spider, etc., you'd have to explicitly say print this thing to the screen. But here, when you're just creating this object, you're not assigning it to anything, it's going to display the result right there. It's going to execute that code and display it. If you're using an IDE to create applications using Python, you explicitly have to use the print function. But this is a notebook. It just wastes a bunch of time. So I've just neatened that up. Let's accept that. And there we go. Look at how lovely that is. So df chest pain type, we've seen this before now. That creates a series object. And I'm going to call the value_counts function. So I'm going to call it a method of this object. Value_counts, open close parentheses. It is a function that's applied to an object that exists with a dot notation. So we're just going to say we're calling the value_counts method. Just learning a bit of the lingo. and look at the results. It's found 4 different kinds of categories for this categorical variable. ASY, I think it stands for asymptomatic chest pain. The NAP for non-angina pain, ATA for atypical angina, and TA for typical angina. I haven't read the data dictionary for this little file. This comes from Kaggle, and I haven't specifically read, but probably makes sense. What I think these abbreviations are for: asymptomatic, non-angina pain, atypical angina, and typical angina. I think that sort of makes sense. But anyway, it gives us the count. It found 496 of the first category, 203 of the second, 173, and 47. So there you have it. What I would like to do is to have a proportion or relative frequency. Let's do that. I'm going to say generate. Let's send or write a little prompt. So calculate the relative frequency of each category in the chest pain type column. So I think you should be more specific and say of each unique value. The large language model, does it understand that this is a categorical variable? I think perhaps it does. Doesn't matter. Let's just send it. And now look at this. It started to learn that I don't want all those print function and assignment to computer variables. It's learning the way that I like things. I've sort of forced its hand. It's learning from the style that I like. And so now it's just doing df chest pain type, creating that series object, then calling the value underscore counts method. But this time it's actually going to use a keyword argument called normalize, and it's setting that value to true. True is a Boolean value. You just get the two, true and false. Internally, they're represented by the numbers 1 and 0. But I like that. I'm going to accept and run. And now we get the proportions. So there was 54% of people with asymptomatic, 22% had non-angina pain, 18.8% had atypical angina, and only 5% had typical angina. So that's great. We get the frequency and the relative frequency, and Gemini has learned that I don't want that elaborate code. Now, please, in the beginning, accept that elaborate code. So what if it's generated a computer variable? So what if it then uses the print function? But, if you've coded in Python long enough, why would you type extra code? Why would you accept extra code? It's already doing exactly what you want. So we have our summary statistics for a categorical variable. Let's create a plot. What plot would be appropriate to this? Well, a bar chart. Let's have a look at that. I'm going to say text. So I've typed generate a bar plot of the chest pain type column. Once again, I'm going to use LaTeX. I'm just sticking to that formatting that I've been using. And let's send the cell. We're going to focus here on that empty cell, sending focus over to our large language model, writing our prompt. So I've written create a bar plot of the categories in the chest pain type column at the title frequency of chest pain types, at the horizontal axis label chest pain type, at the vertical axis label frequency. There's the code, and I'm just going to accept and run, and then we're going to have a look at it. Now that's a bit of interesting information that we're going to get there, and I'm glad this happened. Let's take a look. Instead of using matplotlib, it's now going to use seaborn, so SNS dot, and there's a count plot function. The data is going to come from the data frame object. The x-axis is going to be the chest pain type column. The palette that it's going to use is Viridis. It's the color palette that it's used there. Interesting choice. It's adding a plt.title. So see, we're mixing seaborn and pyplot, matplotlib in other words. It's because seaborn is built on top of, it's got under the hood, it's got matplotlib. So it understands matplotlib, and it's just there to create extra plots that matplotlib cannot create, or easier versions of that, because you can certainly do this with matplotlib, but you're just going to generate a lot more code. And so the count plot just hides some of the complexity that you would have had to use if you're just using pure matplotlib. We've got an X label, a Y label, and show, but now we've got this deprecation warning. And a deprecation warning is saying that you're using some code that is of an older version, and as newer versions come along, they are going to drop this functionality. And so they've changed here. They said using this palette without assigning U is deprecated and will be removed in version 0.14.0. Assign the X variable to U and set the legend to false for the same effect. And so that's quite interesting information. So I'm going to do the following. I'm going to go back here. So if I'm, you know what's happening inside of Python, I would have picked that up before. And or I would have seen this error and say, I can fix this myself, but let's get the AI to do that. I don't want to see this error message. I want, it's working. Plot looks great to me, but I want that error to be fixed. I'm going to go right inside there. I'm still in there. And I'm going to now click inside of my message here. And I'm going to say, something like, look at the error and let's try and fix it. So I'm typing fix the Seaborn coding error raised in the deprecation warning. So the cell is still highlighted. Let's see if it understands that that is where the error is and that, where the error is and what the error is. So let's send that. And now you can see the difference here. You can see the red is the code that existed before. It's going to minus that and it's going to add this green bit. So that's the, just indicating what change is going to take place. So I'm going to just accept and run this. And there we go. So X is chest paint type, the U is chest paint type. So the color is going to come from that and it's going to choose the different colors based on this palette called Viridis, and it's going to set the legend to false because we can clearly just see the names here. Nicely done. See X chest paint type, frequency. We see the title of our plot. Everything works very nice. I think it's cool. I typically would just keep the colors all the same unless you want to highlight a single color, but hey, I think that is great. And so now you've seen how to handle your univariate summary statistics and data visualization, both for a numerical variable and now for a categorical variable. And why don't you try some of the other variables?